Hello everyone, welcome to this presentation. Today we'll be talking about what Industry 4.0 and about cybersecurity as well. And based on this platform, we'll be developing a data logging and monitoring system for an air heater module, a real air heater module. Let's start with the system sketch. Our design will be first start with the control system, which we will be controlling the temperature of the real air heater module with the help of PID controller. This PID controller and a low pass filter is implemented in Python platform. The output temperature from the air heater module will be published to the broker HiveMQ Cloud with the help of by one client, and the code is designed in Python. Client 1 is publishing data. There are other clients, client 2 and client 3. They are actually receiving the data from the broker with the subscribe method. Client 2 is a desktop client and client 3 is a client designed in the Python program. This client 3 not only get data, also log the data in the database. Before implementing our data logging and monitoring system in Azure platform, we'll first develop these methods in local computer. So testing purpose, we'll first log the data in a local SQL database and we'll try to monitor the data from the local SQL database. After this is successful, we'll implement this database in Azure platform. So finally, we'll have a web-based database and web-based data monitoring systems. Let's talk individual elements in detail. Now we'll see the individual component of our system sketch. If you remember our first system sketch, this is just a snippet of front part of our system sketch. Now we will see this part. Here we will see a control system, PID controller, low pass filter implemented in the Python that are used to read the temperature from the real air heater module, and we will also see the temperature data that are published in the HiveMQ cloud, and we will see client 2 MQTT-X getting the data by subscribing method. Now we'll see this part. Let's first go to this Python code. This is the Python code written for reading the temperature and writing the temperature data to the writing the voltage value to the air heater module. Here we have a DAG setting. This is an important part. To read and write the value from the air heater module, we need a DAG device. For this part, we have a setting here for analog input. We have configuration here for DAG system. And here are details about the MQTT details. Broker name, topic subscribed, etc. And if you go a little bit down, in the function named real air heater real, we are reading the temperature data using the function this one, right? And this is a function to clip the output from 0 to 5 volt, and this is the PID controller we are using, and these are PID parameters. It is an important concept to see if these parameters actually perform or actually give the good stability. Realizing the stability of the system using the controller is an important part. We will see that with this parameter our system is stable. The stability analysis will be done little bit, will be shown little bit later at least, because we did this stability analysis at the first, but we will show you that our system is stable with these parameters. Now we will run the system with this code. Here we can see a real air heater model with a DAG device on the top of it. And on the computer we have a Python code running. Now let's turn on the real air heater model. When this real heater model run and we run the Python code, we will see the temperature reading from the real air heater model. As you can see, we have reading temperature signal and the control signal both from the to the real air heater model. If we go on analyzing the temperature data, which we will see later on the plot. These temperature data are getting set to the required reference temperature value. That means our PID controller is working fine to make the output temperature of the real heater model to the reference point. The control temperature from the air heater model are now plotted. You can see the output temperature T out is settled to the reference temperature 27 degrees Celsius. This is our control signal that is generated by the PID controller. As you can see, little bit fluctuation. This can be smooth with a strong filtering. That means our PID controller to control the air heater process is working fine. Now we will see the whole process from the MQTT broker to the database, data in the database. For demonstration purpose, we will run a simulator. Here is our simulator running, and we will run a subscribe client because in this simulator I have already included, we have already included the client publishing data. Now we'll run a client subscribing data. And this client not only subscribe data but also put the data into the database. Let's run this one. As you can see, this is already connected successfully to this MQTT broker and we are receiving data. As you can see also here, the temperature here is one client subscribing the temperature data, and here we have one client subscribing the temperature data, and we are sending data to the MQTT Hive from here, from the simulator itself. So we are getting temperature here and we have temperature also here. This is the MQTT X client running in the desktop. So now we go to database. As I have already loaded this temperature data which were all previously recorded here. Now we will refresh the database. I just got it. No. Refresh. Also one more thing. Here I am not connected to the local. I am connected to the database which is already implemented in the Azure, that is cloud-based database. Now I go to query, select all from measurement data and execute. So we can see here all these temperature data are recorded here in the database with timestamp, measurement value, and its unit is degrees Celsius. In this way, we have implemented the data and the database that is based on Azure service. Now we will see how we can access this database from the using web service. Now we will monitor our database, the database that is already present in Azure platforms using the web services. Our link for this database monitoring is this. If we click this one, we have a page open here. It says welcome data monitoring application for air heater model, and we have here these things. And if we click this air heater temperature tab, then we will be able to see the temperature data in our database. As you can see that these are the data that are already present in the database and we are monitoring them from the web services with this help of this link. Okay, yeah, with all this we have made a data monitoring application. Now we see if our system is stable based on the poles plot. As you can see, the poles are on the left hand side of the real axis. That means our system is stable. Now if our system is secure, we will see that. That means if we are dealing with the clouds and internets, we may have different issues like hacking, cyber attacks, and cyber threats if we do not make our system resistible against these things. So to make our system secure, we can implement either passwords, users identity, login, two factors authentications, firewalls, antivirus, etc. Also in our system, to protect privacy things, we should implement GDPR policy. But these policies and the system security things yet to be implemented in our system. Thanks.